Hello, everyone. Welcome to the RCNP course. In this part, we are going to use the AAA basics. And about the basics, actually, you should know that in some network with high security requirements, such as the financial institutions and schools, end user-based access authentication is used for port controls. And customers want their devices' accounts and passwords to be secure and easy to remember. If number of devices is high, accounts and passwords of these devices should be managed and configured in a unified manner. So if we want it to be easier to remember these accounts, we should have unified accounts and passwords of all devices. But it brings a problem. If all the devices have the unified account and password, it's not that secure. So to strengthen the security, we should periodically update the passwords. In authentication, AAA architecture, AA represents authentication, authorization, and accounting. Reduce and the TACAS+, two AAA protocols can be used to implement user-based access and uniform management of accounts and passwords. And at this part, we will focus on the Reduce and the TACAS+, these two protocols. First, of course, let's see some basic information about the AAA. AAA provides a framework for configuring the authentication, authorization, and accounting security functions. Configuring AAA is in fact management of network access controls. But I think you could get a little confused about what's the meaning of AAA. It's accounting, authorization, and the authentication. The first thing about the authentication, it authenticates user identifiers to decide whether to allow a user to access a network. So in other words, authentication is used to determine if this user is allowed to access or not. And authorization is used to determine after accessing the network, what this user can do. Here it says assigns permissions to users to control the network services available to a user. So what you can do. And accounting records network resources used by a user to build the user property. It means that after accessing the network, what you did, right? So it's used to record what you did. And user remote server, no matter it's Reduce or TACAS+, or even switch as the local authentication server is available, or is the solutions nowadays were mostly used. You can see in the network, we have, for example, Reduce server or TACAS+ server or backup servers. And backup server obviously is just a backup to improve the reliability of the network, right? And the host will send the username and passwords when they want to access the network. And this username and the password will be sent to the servers. And of course, the servers will verify these usernames, these passwords, and feedback the results. After getting the result, the hosts can access the network or will be refused to access the network. It's about the results. And about AAA, let's take an overview of this. The following authentication methods are supported, depending on the entity providing authentication. The first is the authentication free, or even you can see is non-authentication. No authentication is performed on user validity, and this method is not recommended because it's not secure, right? Obviously. And next is the local authentication. The NAS database is used to manage user information. User information includes the username, the passwords, and some other attributes, and to verify user identities. And the third is the remote server group authentication. The remote server group could be a radio server or could be a TACAS Plus server, right? The user database on a remote server is used to manage user data for user identifier verification. This method provides centralized authentication that features large capacity, high reliability, and support for multiple devices. Of course, if we use the remote server group authentication, we could have a authentication server, and it can manage all the devices in this network in a uniform method, right? And it can improve the reliability and support large capacity. And this method supports reduced TACAS Plus servers, which we have just mentioned. And except that the following authentication types are supported depending on the user access methods. Login authentication for users accessing the network from an SSH, Telnet, FTP terminal. Login authentication verifies the identity of a user when the user logs in to the NAS CLI. So normally when you use Telnet or when you use SSH, this kind of remote accessing tools to access maybe a CLI of a device, normally you are required to enter a username and a password. Right? This is called login authentication. Next is the enable authentication. After the user logs into the NAS CLI, enable authentication verifies the identifier of a user when the user tries to extend CLI permissions. That is, verifies whether the user is allowed to enter the privilege mode. Because as we all know that the CLI have different privileges, and the enable authentication means you want to get a higher permissions. So you should pass the enable authentication. And of course, you should enter the password, right? And next is 802.1x authentication, verifies the identifier of a user who tries to gain access through IEEE 802.1x, or FTP authentication, verifies the identifier of a user who tries to gain access through FTP. If FTP authentication is not configured, login authentication is used to verify users who try to gain access to a network through FTP. Okay, this is about some authentication types, right? And which of them are mostly used are login authentication and enable authentication. It's very common in the network. Okay, next, about the radius and the TACAS Plus. Radius stand for remote authentication built-in user service. TACAS Plus stand for terminal access control system. And then let's see some difference between them. For the transmission protocol, radius use UDP 1812 for authentication and authorization, while UDP 1813 for accounting. For TACAS Plus, it will use TCP 49 for authentication, authorization, and accounting. And for the packet encryption, radius encrypts access request packets, while use plaintext for other packets. Different from that, TACAS Plus encrypt all packets except for data packet headers. And about the authentication and authorization, radius accept packets contain authorization information. Authentication and authorization cannot be isolated, while TACAS can isolate authentication, authorization, and accounting is supported. About the functions, radius cannot be used to authorize user executable command permissions, mainly used for user access authentication and accounting. While TACAS Plus can be used to authorize user executable command permissions and mainly used for device management. And actually from here, we can find that the TACAS Plus is more accurately control the authorization of users when they want to manage the device. Okay, and Next is the compatibility. Radius is extensible for private attributes, while it may bring the compatibility issues. While Takas Plus is a Cisco proprietary protocol, and actually in the real application scenarios, it's a unified standards. Okay, after knowing the basic information about these two protocols, next we are going to introduce each of them one by one. Firstly, let's see the Takas Plus principles and the typical configurations. Now, in this figure, you can see a user which is connected with the network device, and then it's a switch. The switch is connected with a Takas Plus server. Actually, the switch in this slide acts as the Takas Plus client. If the user wants to access the device, firstly, it will send a message to the network device. It will initiate the login. And after receiving that, this network device will send an authentication request to Takas Plus. Means now someone wants to access me, so we need to do an authentication right now. After receiving a request, Takas Plus will say that, okay, it's a response, and what we need right now is your username. So respond and request username. This packet will be sent to the user, request the username from the user. And after receiving the request, user will send the username, right? User enters the username and will send the username to sustain the authentication. After knowing the username, next, Takas Plus will respond and request the password. So you can see the user will receive a message, which is a request password from the user. Okay, so I will enter the password and send the password to sustain the authentication. After receiving the password, Takas Plus can verify if this password is correct or not. So it will respond and approve the authentication if the password is correct. Okay, and since until now, until number 11, we have finished the authentication. So next is the authorization. The network device will send an authorization request to the Takas Plus server, and the Takas Plus server will respond and approve the authorization. Because based on the username and the password, the Takas Plus can know the authorization of this user and will respond and approve it to the network device. After finishing the authentication authorization, obviously the next step is the accounting. So let's see. The network device will firstly feedback a result that the user logged in successfully. And then once the logger successfully logged into the device, we should start accounting. So it will send an accounting start request to the server, and server will respond, right? Accounting start response. And this time, the user can really access the resources it needs. And maybe after a moment, the user wants to log out. And once the user log out, we should end accounting. So the network device will send the accounting end request to the Takas Plus server, and Takas Plus server will feedback accounting end. This is about the process, how it works when we use the Takas Plus to do the authentication, authorization, and accounting. Okay. After knowing the process, next, let's see the Takas Plus packet architecture. Since all the packets exchanged when we use Takas Plus, they will contain a lot of messages, and these messages have a structure when it's carried in the Takas Plus packet. Okay, let's see it. First is a major version, is a major Takas Plus version, and minor version. You can see major version is here actually, right? And minor version is a manual Tagas Plus version. This version can be modified to support downloads capability. And next is a packet type. It uses different numbers to represent different types of packets. Tagas Plus also means it's an authentication package. And obviously, this is an authorization. Tagas Plus ACCT is accounting. So we have 3 different packet types: authentication, authorization, and accounting packets. Okay, next field is the sequence number of the data packet in the session. Flags indicates whether to encrypt data packets. And the session ID is the ID of the Tagas Plus session. Length obviously is the length of the data packet body. And the length here do not include the header length. Okay, next, let's see the Tagas Plus basic configuration. And the first step of the configuration is to enable AAA by using the command AAA new model. By using the command AAA new model, and next configure the Tagas Plus remote server, Tagas server host with the IP address. It could be a IP version 4, IP version 6 address. Next is the port number you use. And if it's a single connection, you just need to use a command single connection. And the test username is the username which you use to test. Okay. And the idle timeout is a period. Right? It's 2 timers. And the next is a key. Key have 2 types, 0 and 7. 0 means it's plain text, while 7 means it's cipher. Okay, and followed with the key. Okay, with the key on both sides when they do the authentication. And next is optional configuration. Configure the source address for Tagas Plus packets. By default, the source address is set by the network layer. And the command is quite easy. IP Tagas source interface. First is the interface type and the interface number. It could be a physical interface, or it could be maybe aggregate port. For example, G00, G01, just like this. Okay. And next, let's see the application scenario of this protocol. In a network, a Tagas Plus server, it could, for example, is a RCNP, right? It's deployed to verify the identity of a user who attempts to access devices. All accounts are generated and maintained by this server. The requirements are as follows. From the requirements, we can find out what we should configure. Right? The courseware supports only SSH. If we want this device only support SSH, so maybe we should disable some other protocols. Right? From IP address 172.16.101. So here is another limitation. Only allow SSH login from a specific IP address. So maybe here we need to use the ACL to control this. Console port login uses the local account and the password. The Tagas Plus server needs to authenticate, authorize, and account user logins. After 3 consecutive login periods, an account will be locked for 15 minutes. This is another requirement. So to satisfy these requirements, let's see what we should do. User logins need to be authenticated by the Tagas Plus server, and the key points are listed here. On the Tagas Plus server, configure device information and add login users. Enable the AAA secure service on the device. Configure Tagas Plus information on the device, and configure Tagas Plus authentication method list. Apply the Tagas Plus authentication method to certain links. After knowing these key points, next let's see the commands. Username, Ruijie, password, Ruijie at 123. Configure the local username and the password. This is used for the console login, right? And enable secret 0, Ruijie, configure the enable password. Here, pay attention, zero is this number, zero reference. It's not a ciphertext, it's a plain text. Enable service SSH server. So we have enabled SSH. Since there is a requirement, if you still remember, you will know that we only allow SSH. So pay attention here, no enable service telnet server. So we have disabled the telnet. Only SSH is allowed. And another requirement is that only the IP address 172.16.101 can access the core switch. So here we use ACL to do that. IP access list extended 2000. This is an extended ACL. Permit IP host 172.16.101. This is the source, and any means the destination could be any. Okay, and next, let's see. Config Tagas Plus login authentication. Firstly, enable AAA, AA new model, Tagas server host 10.10.10.10, key 0 Ruijie. Key 0 means it's a plain text, right? And the AA authentication login VTY group. Here, VTY is the name, indicates the list name, and the group defines the authentication methods, which are Tagas Plus and local authentication. So Tagas Plus and local. And next, AAA authentication login default local means use local authentication for the default authentication list. And for the line VTY04, we are entered the VTY configuration mode. Login authentication VTY means we will use the VTY we just configured, invoke the VTY authentication list here. Access class 2000 in, invoke the ACL 2000 we just configured to limit the login IP addresses. In this way, we can ensure that only the IP address 172.16.101 can access. Line console 0, enter the console mode after AAA is enabled. Default authentication list is invoked here. Okay, and next is the configuration of Tagas Plus login authorization. AAA authorization EXEC and followed with the name. Configure the EXEC auth authorization list. Group Tagas Plus local means we support Tagas Plus and local. And the line VTY04 authorization EXEC AOTH. Here we just invoke the authorization we just configured. Okay, and the next config, the Tagas Plus command authorization means the authorization of the user. AA authorization command 0, 1, 2, 3 until 15. Default group Tagas Plus local means they belong to the default group, right? And the Tagas Plus and local are available here. Number here indicates the different privileges of commands. Okay, and config the Tagas Plus accounting. The command is right here. AAA accounting command 0. Command account. This is a name, right? This is a name. Start, stop, group Tagas Plus. Start, stop means we will record the start and the stop of a user after accessing the network. And next configs Tagas Plus accounting. We invoke them in the VTY configuration mode. Okay. And at last, config the Tagas Plus extended features. For example, AAA local authentication attempt 3. Attempt 3 means you can try for 3 times. Well, if you still failed at the third time, there is a requirement that it will be locked for 15 minutes. So AAA local authentication lockout time 15 indicates that once you have failed the authentication for 3 times, this account will be locked for 15 minutes. And next, if you want to manually unlock an account, just use command clear AAA local user lockout username. Here you should enter the specific username you want to unlock. Okay, and about the Tagas Plus, here are some precautions you should know. The Tagas Plus secure service belongs to the AAA service category and needs to be enabled using the AAA new model commands. TAGAS Plus basic configurations only provide a security service. TAGAS Plus functions take effect when you designate the TAGAS Plus service when configuring AAA master lists. And when configuring TAGAS Plus for networked devices, use a console cable to avoid device management failures caused by incorrect configurations. Means, for example, you enter you configure the number which is not the same as you remember, so you cannot access the network. At this time, you can use a console cable to log in and manage the device. The shared key configured on devices must be the same on both sides, as that used by the TAGAS Plus server. This is about the precautions if we use TAGAS Plus. And except the TAGAS Plus, there is another protocol called Radius. So let's see the principles and configuration of it. If we use Radius, the user will enter the username and the password. Then the network device will send authentication request containing the username and password to the server. The server will respond to the request, accept it or reject it. This is the result of authentication. And next, send a counting start request only when the result is accepted. So we will start accounting. And after receiving that, the server will respond to the accounting start request. And the user can access the resources from this point. And next, send the request to end accounting when the user wants to log out. And of course, there will be a response. And after receiving the response, the network device will notify the user of ending access and the user is offline. Okay, and the next is the Radius packet architecture. Let's see it. In the Radius packets, there are some fields. The first field is code. It's 1 byte long, used to indicate the Radius packet type. If the value is invalid, the packet will be discarded. Next, identifier used to match response packets with request packets. If the Radius server receives multiple packets from the same IP address and port with the same identifier, it considers the request to be duplicated. And next field is length. It's 2 bytes long, used to indicate valid packet length range. Bytes exceeding the upper limit will be discarded. If the packet length is shorter than the lower limit, the whole packet will be discarded. Next field, authenticator, used to authenticate the validity of packets between the Radius server and the client, specifies the passwords containing algorithm. And last field is attributes. Attribute chain consisting of business required attributes and optional attributes. The length of this field is variable, okay? And after knowing these fields in the Radius packet, next let's see the Radius header field. In the Radius header field, the code indicates the packet type. Code 1 is the access request from a NAS device to the server, indicating username, NAS IP, port number, this kind of information is carried. Code 2 is access accept, and code 3 is access reject. It's a response from the server to the network device to notify the results of authentication. It's accepted or it's rejected, right? And for the accounting packet, the code is 4 reference is a accounting request from a NAS to the server, and is sent after the user is authenticated. While code 5 is the accounting response from the server to the NAS device, indicating that the accounting starts. Okay, and about the attribute field, it contains authentication, authorization, and accounting information. And let's see what are they. Firstly, the type. The value is 1 byte long. Attributes that cannot be identified by the server and client can be discarded. And the length used to indicate the length of an attribute. Value, this field is 0 or multiple bytes long, containing details about the attribute. The format of this field is determined by type and length. So it's called TLV. It's a very commonly used architecture of packets in the network. For example, ISIS packet also use the TLV structure, and the BGP package also use the TLV package. The most obvious advantage of this structure is that it's very easy to extend the function of the packets. Okay, and about the attributes, here you can see some common attributes. For example, username, filter ID, user password, NAT IP, from the IP, login service, vendor specific, calling station ID. This kind of attributes can be carried in the packets by using different TLVs. Okay, and about the radius authentication, let's see some typical methods. First, TAP and PAP. TAP is a challenging handshake authentication protocol, transmits password hash value, while PAP transmits password in plain text. It's a main difference between PAP and TAP. One is a hash value, the other is the plain text. And next, the PAP. PAP does not specify an authentication method, but provide additional security for other EAP authentication methods, such as EAP MSC chat words 2, which is implemented using encrypted channels provided by PAP. And next is the EAP TLS. EAP TLS, this protocol designed for digital certificate authentication, which requires that both the user and the server have their own digital certificate. The authentication is based on the public key interface, or we call it PKI system, which issues digital certificates to users and the server. And the PAP MS Chat-V2 is a wireless authentication protocol supported by most mobile terminals. This protocol transmits PAP-protected user authentication information. Passwords cannot be decrypted. Therefore, this protocol is recommended for wireless authentication deployments. Because the passwords cannot be decrypted, so the users actually do not know the exact password. It's more secure. Okay, after knowing this, next, let's see the configuration. The radio-specific configurations on NAS devices. And here you should know that, here's a note. Ensure good network communication between devices and the radio server before configuring radios. And the first step is to enable AAA. It's the same as we did when we configured the Tagas Plus, right, AA new model. And configure the radius remote server, radio server host, and the IP address, the authenticated port, accounting ports, of course, for the authentication and the authorization port. And about the accounting port, you can just use the default port number, right? And the test username and ignore accept ports, the idle time, the key, appreciate the key of both sides, is similar to the configuration of the Tagas Plus. And configure shared key for information between devices. You can use a specific command to do this, or you can just add it in this command. The function is similar. Okay, and optional configure the radius packet source packet address. By default, the source address is set by the network layer, and the command is IP radius source interface G00, G01, or it could be a aggregate port, right? It's similar to what we just introduced. And configure the source UDP port for sending radius packets. And by default, devices use a random UDP port to send radius packets. If you wanted to use a specific port number, you can use this command to configure it. And after knowing this command, let's see in case network requirements is shown here. Radio server is used by logging users for authentication, authorization, and accounting. And we should configure device information and add logging users on the radio server. Enable AAA security service on the device. Configure the radio server information on the devices. Configure radio's authentication, authorization, accounting method list. Apply to certain links. This is the requirement, and let's see the commands. Firstly, enable AAA, AAA new model, and set the radio server host. This is the IP address. This is the pre-shared key. And the key here should be the same as that on the radio server. AA authentication login radios method is group radios. Configure the authentication list, and next command is the authorization list and accounting list. Then line with TY04, we should apply the authentication, authorization, and accounting methods to the interface. The method to apply them is shown here. Login authentication radius method. On authorization EXEC radius method. Accounting EXEC radius method. So from here, actually, you can find the configuration of radius is a little simpler than that of the Tagas Plus, right? Okay, after knowing this, next let's see some questions. From these questions, we hope you can do a review of what we have just introduced at this part. Which of the following statements about AAA is incorrect? A, AAA is short for authentication, authorization, and accounting. It's true, or it's correct. B, it has two sub-authentication protocols, Radius and Tagas Plus. Yes, it's correct. C, both Radius and Tagas Plus implement complete installation of authentication, authorization, and accounting. No, I know. Of course, Radius cannot isolate authentication and authorization. And D, Radius is based on UDP, while Tagas Plus is based on TCP. It's correct. Here we choose C. Okay, here we choose C. And at last, let's see a summary. AAA is short for authentication, authorization, and accounting. The authentication protocols are Radius and Tagas Plus. This is the main points of what we want to introduce at this part. Thank you for your time.